Hi, very good morning to all. So, hi, hello, I am Rajendra from Ask Engineering Academy, Hyderabad. So, we will going to be discuss today about the ECE and EEE. There is a common subject is called mathematics for gate examination. So, this examination for a gate, Laplace transformation concept is the one of the essential tool to solving the control systems and signals and systems problems that we can discuss today, that is Laplace transformation. This is a Laplace transformation which is the links to the one is the controls signals, okay, and there is a mathematics. One of the syllabus is given in the as per the syllabus of the GATE 2025. Okay, please listen carefully. Laplace transformation, what is the definition of the Laplace transformation and how the Laplace transformation will be used to designing the systems, that formulas we will discuss today. Okay, right. So, first Laplace transformation is a device which is a tool which can be used as transformation, which can be used as, it is a tool which can be used as to transfer a time domain function to the frequency domain function. It is supposed to f of t is there. This is a Laplace transformation of, let us say, f of t, which is equal to, will be represented Laplace transformation capital L integral from 0 to infinity e power of minus st into f of t dt beta. Okay. So, for this is equal to f of s. Normally f of s is the frequency. Here ఇక్కడ t అనేది ఏంటంటే టైమ్ డొమైన్ సిస్టమ్, టైమ్ డొమైన్ ఫంక్షన్ ఆర్ సిస్టమ్ విచ్ ఈస్ కన్వర్టెడ్ టు ద s. s is called frequency domain. Frequency domain అంటే ఇక్కడ ఏంటి, time is converted to the frequency domain. S means j omega here, j omega, where j into omega means 2 pi f beta, 2 pi f. So, 2 pi is constant, j is constant. Now, f is called as a frequency, right. So, now we are transferring the time domain function to the frequency domain function f of s. Okay, this is called Laplace transformation, but inverse Laplace transformation is simple. So, it is f of s to f of t. That means, so f of s inverse Laplace transformation will be f of t. It is a dual in nature. Okay, once we can convert to the time domain to frequency domain to time domain, that can be possible with the Laplace transformation. Now, so we can see some basic functions Laplace transformation, basic functions of Laplace transformation. Example is Laplace transformation of e power of at. So, this Laplace transformation equal to integral, same formula, 0 to infinity e power minus st. So, f of t, instead of f of t there is a e power at, then we can write the e power at into f of t. Instead of f of t we are taken e power at into dt beta, right. So, integral 0 to infinity, here bases are equal, power should be added, that is the reason we can take it as a minus st plus at into dt, right. So, here integral 0 to infinity beta e power minus t, if I common, s minus a will coming, so into dt. Now, integration of e power at will be e power at divided by a. Normally integration of e power at into dt will be equal to e power at divided with its coefficient of t will be a plus c will written. In this way we can written. Similarly, here e power of minus t into s minus a divided with t coefficient, what will be there, minus of s minus a is there. So, from 0 to infinity. So, if I substitute upper limit as infinity at that moment at the t value, so e power minus infinity value is 0, that is 0 minus e power t, instead of t we are substituting here 0, that value is e power 0 will be 1 divided with minus of s minus a. Here minus 1 minus cancel, 1 by s minus a. So, this is a Laplace transformation of e power at will be 1 by s minus a. Suppose to, this is the first thing, we can also written e power of minus at Laplace transformation is what actually. Here at will be 1 by s minus a, 1 by of s minus of minus a will becomes 1 by s plus a beta, 1 by s plus a. So Laplace transformation of e power at will be 1 by s minus a, but Laplace transformation of e power minus at will be 1 by s plus a. అంటే ఇక్కడ మైనస్ ఉంది కాబట్టి 1 by s minus s plus a వస్తుంది, బికాస్ రీజన్ ఈజ్ ఇందులో మైనస్ ఉంది కాబట్టి. ఓకేనా? సో దిస్ ఇస్ ద బేసిక్ ఫంక్షన్. బట్ ఎగ్జామినేషన్లో సివిల్ ఇంజనీరింగ్ కానీ మెకానికల్ ఇంజనీరింగ్ కానీ డైరెక్ట్ క్వశ్చన్ వచ్చే అవకాశం ఉంది. బట్ ఎలక్ట్రికల్ ఆర్ ఎలక్ట్రానిక్స్ ఇంజనీరింగ్ స్టూడెంట్స్కి మాత్రం ఈ కాన్సెప్ట్లో కొంచెం డెప్త్గా వస్తాయి క్వశ్చన్స్. సో ఆ డెప్త్ క్వశ్చన్స్ మనం నెక్స్ట్ లెవెల్లో డిస్కస్ చేద్దాము. రైట్, ఇది వన్ ఆఫ్ ది బేసిక్ ఫంక్షన్. నెక్స్ట్ బేసిక్ ఫంక్షన్ ఈజ్ సపోజ్ టు సైన్ ఆఫ్ ఏటీ Laplace transformation is what actually? Sin at Laplace transformation. So that is equal to e power 0 to infinity beta e power minus st as per the definition sin of at into dt beta. Okay, so here we have some formula here. That formula you can represent it. Can I represent here? So e power at into sin of bt. Suppose to this is the integration dt beta. This is a integration of the e power at sin bt formula is what actually? That is equal to same e power at you can represent it, divide with t coefficient, that is a square plus b square. Okay, so ikkada a into em raskovalante the same function whatever it may be there, that sin of bt you can written here plus ikkada next enti b coefficient into sin యొక్క ఇంటిగ్రేషన్ ఏంటిది, minus cos bt. Here can I represent this is minus, here can I represent this is minus. Okay, so this is the integration formula for the which one, integration of e power at sin bt. So this is a formula. As per this formula, if you can implement here, as per this formula if I implement here, e power of minus st divide with here s square is there, s is there, minus s is there, minus s whole square plus a square into here minus s into sin of at plus minus of bt. Here b means a into cos bt. Cos b means here it will be a, b means at, right? So we are applying the upper limit minus lower limit rule here. 0 to infinity we are applying, 0 to infinity. So when you are apply this infinity, e power minus infinity will be 0. 0 into something will be 0. So that is the reason I can represent this is 0 minus lower limit value we are substituting. This lower value is 0, e power 0 will be 1 by s square plus a square into minus s into sin 0 value is 0 beta plus here it will be minus a into cos 0 value is 1. Okay, this closed. Here this minus will becomes plus. Now a divided by s square plus a square beta, s square plus a square. Now sin at formula is a divided with s square plus a square is the your answer. Okay, now suppose if you take the sin of 3t value కావాలనుకో అప్పుడు ఏమవుతుంది, instead of a you can substitute 3 divided by s square plus 3 square will be 9. sin of t కావాలి సపోజ్ నీకు, అప్పుడు ఏమవుతుంది, t అంటే దీని కోఎఫిషియంట్ ఎంత బేట 1 by s square plus 1 square will be 1. So as this way you can calculate the value of the sin at, sin 3t, sin at, sin 2t, sin 1t, any value you can do it on this procedure. Okay, so this is one of the standard formula. Next standard formula is Laplace transformation of cos at తీసుకుంటున్నా suppose to. So what is a cos at Laplace transformation that I can represent it? Integration from 0 to infinity as per the definition e power minus st into cos at into dt beta as per the definition. But we need some formula here, integration formula. That integration formula will be taken in the e power of at cos bt supposed to will be there into dt. So the integration of this value will be equal to e power at divided with t t coefficient square a square plus t coefficient square b square into here a value whatever it may be you can return a value. So into cos bt beta plus ఇక్కడ b into cos యొక్క ఇంటిగ్రేషన్ చేసినప్పుడు you will get the positive sin value. సో అందుకే పాజిటివ్ తీసుకుంటున్నా sin bt. So over this is plus c after integration will be completed, that is indefinite form of integration. So integral sum 0 to the same formula I am applying here. So e power minus st divided with minus s whole square plus here a is there then a square into minus s into cos of at plus ఇక్కడ ఏ వాల్యూ ఏదైతుందో ఏ వాల్యూ సేమ్ sin at. So upper limit minus lower limit we need to substitute here, 0 and infinity we need to substitute 0 and infinity. So e power 0 value is already I told that is 0, this is 0 content, 0 in divided by something is 0, 0 into something is 0 minus e power 0 value is 1, e power 0 value is 1 by s square plus a square into minus s into cos 0 value is 1 plus 0 sin 0 value is 0. Okay, this minus becomes plus s divided by s square plus a square. So what is the Laplace transformation of cos at means s divided by s square plus a square beta, s square plus a square, that is the Laplace transformation of cos at. If suppose the examiner will ask you like this, cos of 3t Laplace transformation is what beta? Is s by s square plus 3 square will be 9. So sin of 3t ఏమవుతుంది? This is different again. So previous formula, that is equal to ఏదైతే numerator లో constant will be coming, what is the constant here? 3 is there. So 3 divided by s square plus 3 square will be 9. So these denominators are similar here, similar, but numerators will be always changes. If it is cos you will get the s as a numerator, if it is sin the numerator will be constant, that is t coefficient of any value, right? These 3 standard formulas we completed. Again one more standard formula is, suppose to k is there, Laplace transformation of any constant, that is equal to integral 0 to infinity e power minus st into k beta into dt. So integration whenever you are doing, the variable of integration is here t, that is the reason k is taken as a constant. Okay, integration from 0 to infinity e power minus st into dt beta. Okay, so here k into this value is e power minus st divide with minus s. So ekkadi నుంచి వరకు ఇది 0 to infinity. So this is k into, so if I substitute 0 here, that will be e power infinity is 0 minus this is 0 will be 1 by minus s. So this minus will be cancelled, k by s beta. Now the Laplace transformation of 1 will be 1 by s, because k will be k by s, okay, any value k means 3 will be Laplace transformation of 3 will be 3 by s, like this you can represent. This is the one more standard formula. Next standard formula is, suppose to t power n Laplace transformation is what, which is equal to n factorial divided by s power n plus 1 t power n, that is a standard formula. One more thing is I can written here sin ht, sin of het. What is the Laplace transformation of this function? This is equal to, can I represent sin at can be represented as a e power of at minus e power minus at divided with 2 beta, because I can apply this way. Sin h can I represent in this way, right? So 1 by 2 is constant beta, Laplace transformation of e power of at, then minus Laplace transformation of e power minus at. Okay, as per our discussion we discussed just now, 1 by 2 into e power at means 1 by s minus a minus e power minus at means s plus a. Already we discussed this part in the first point. 1 by 2 into, if I take the LCM, s minus a and s plus a. Okay, so this is s plus a minus of s minus a. Okay, so here minuses pluses will be cancelled out. Minus a plus 2a by, this is a plus b into a minus b becomes a square minus b square, s square minus a square, 1 by 2. 2 gets cancelled out, then a by s square plus minus a square. The Laplace transformation of sin HET will be a by s square minus a square beta. This is the one of the important formula again. Right, next one. Cos HET Laplace transformation is what? That is equal to, first cos h we can convert to the exponential format. So that is e power at plus e power minus at divided with 2. So this is Laplace transformation we required. So then, so individually we are applying 2 is the constant, Laplace transformation of e power at plus Laplace transformation of e power minus at, okay, 1 by 2 into, so e power at will be 1 by s minus a, this is total entire bracket, okay, 1 by s plus a beta, okay, then 1 by 2 into LCM, if I do it, s minus a into s plus a, then it will be s plus a plus s minus a. Here minus a cancel out. So 1 by 2, s plus s will be 2s by s square minus a square, 2 gets cancel out. This is s divided by s square minus a square. Now the question is here, what is the answer of this value? S by s square minus a square beta. This is the answer. So as per as we discussed some things that I will notice here, that we can notice here, some of the points we can notice here. What is the Laplace transformation of k will be k by s beta. K Laplace transformation is k by s, and this is a Laplace transformation. Laplace transformation of e power of at will be 1 by s minus a. So Laplace transformation of e power minus at will be 1 by s plus a. Okay, then Laplace transformation of sin at will be what actually? A by s square plus a square. Okay, here I am doing here sin of HET, sin HET Laplace transformation. Here h is coming, the numerator part, denominator part plus will be becomes minus a divided by s square minus a square beta. That's part. Next, Laplace transformation of cos at will be equal to, cos at will be equal to s by s square plus a square beta, right. So if it is Laplace transformation of cos HET will becomes what actually? Same formula, but instead of minus, instead of plus you can substitute here minus, s square minus a square. Okay, you will easy to remember some things here. Sin and sin, the numerator will be constant. For a cos, numerator will be s. That is the first point. If it is supposed to h, the denominator value instead of s plus, s square plus, it will be becomes s square minus. Okay, this part is very important. Next, Laplace transformation of t power n, which is equal to n factorial divided by s power n plus 1. Okay, so these are the required formulas for the Laplace transformation. So this is a basic class. So this is one of the basic class. Basic class for GATE 2025 batch BTech students, for a BTech who is studying for the ECE or EEE students, EEE or ECE students. So you will get the complete videos for mathematics only, and this will be uses for your academic exams even. Okay, thank you so much.